Welcome you all. This is the second part of the weathering processes. In the previous part we have seen the physical weathering and now we will deal with the chemical weathering. The chemical weathering involves changes that can alter both the chemical and the mineralogical composition of the rocks. So this is mainly done with the help of some aqueous solutions that is present in between the rock fractures or the cracks and results, and this will react with the mineral present in the rock and result in some kind of mineralogical or the chemical changes in the rock. So there are different types of the chemical weathering process: the simple solution or the congruent dissolution, hydrolysis, oxidation and reduction, hydration and dehydration, ion exchange, and chelation. One by one, we will see the different types of the chemical weathering process. Before that, we will deal with the factors controlling the decomposition. There are different factors that results in the decomposition of the mineral, and thus the different minerals decompose at different rates. The different factors include like the climatic factors such as temperature range, rainfall and groundwater level, organic factors such as vegetative cover, soil communities and bacterial activity, soil water geochemical factors such as ionic concentration, acidity, alkalinity and the oxidation and reduction potential, and the last one is the topographic factors such as slope. So the first one is the simple solution. Simple solution is also called as the congruent dissolution. This process occurs when a mineral goes into solution completely without precipitation of other substances. And this simple solution generally occurs with highly soluble minerals such as calcite, dolomite, gypsum, halite, but not with quartz, which are very resistant. Thus, the H2O or the H2O plus CO2 present in the water or the solution will react completely with the rock minerals. The example is like quartz SiO2 plus reacts with water to give the silicic acid, and the second one is calcite plus H2O plus CO2 will react to give the cation and the anion part like Ca2 plus and 2HCO3 minus. The second process is the hydrolysis. The hydrolysis is one of the extremely important chemical reaction that occur between the silicate minerals and acid, and it leads to the breakdown of the silicate minerals and the release of metal cations and silica. But this reaction does not lead to complete dissolution of the minerals like that we see in the simple solution. So the reaction occurs between the H plus and OH minus ion of the water and the ion of the silicate minerals. For an example, the orthoclase will react with H plus to give kaolinite and silicic acid and will give out the K plus ion. Similarly, albite will react with H plus along with water to give kaolinite, and here it will give the Na plus ion. The next one is the oxidation and reduction process. The oxidation and reduction is generally the loss or the gain of the electron from an element of a mineral, resulting in the formation of a more oxidized compounds. For an example, from the perspective of the geological processes, like the most common example is of pyrite. The pyrite is FeS2, which is a sulfide, will react with water in the presence of the oxygen and give out hematite, which is Fe2O3. Thus, if we are getting hematite in any area, we will see that the environment is oxidized environment. And if in other case, the reverse is if we are getting pyrite, we generally say it is formed in a reduced environment. The other most common example is of rhodonite. The rhodonite, which is the Mn silicate, this will react in the presence of oxygen to give out pyrolusite. The another processes are the hydration and dehydration. Dehydration and dehydration refers to the gain or loss of the water molecules from a mineral resulting in formation of the new mineral. So if the water is present, it will add up to the formula to give out a new compound. Like hematite will react with H2O to give goethite, and gypsum, which has already H2O present in its formula, if in dehydration process, it will give out H2O. The other two processes are the ion exchange process and the chelation process. This chelation process generally occurs in the presence of some chelate cations. This chelating substance will add up and form bonds with the metal ions or the organic substance to form the organic molecules. So thank you and stay tuned for the next session.